Hello, today I'm showing you our price similarity network analysis project. Our goal is simple. We want to see which cities in Pakistan have similar inflation patterns by looking at price data from 2023 and 2024. Why is this important? When we know which cities have similar price changes, the government can better understand how inflation spreads from one city to another and make better decisions. We use something called cosine similarity. It's a way to measure if two cities' prices move in the same direction over time. Not if they have the same prices, but if they change in the same way. Then we build networks to see which cities are connected. This helps us turn regular price data into useful information about how city economies are connected. Let me explain how we do the math. Building vectors. For each city and each category, like food or transport, we make a list of build prices, one for each month. So Lahore's food prices become January price, February price, and so on. This list captures how prices change over time. Normalization. This is really important. We use something called z-score to adjust the numbers. Why? Because we want to compare patterns, not actual price levels. If one city has higher prices but changes the same way as another city, we want to call them similar. The formula is simple. Z is equal to price minus average over standard deviation. Cosine similarity. Now we compare every pair of cities using this formula. Similarity is equal to A times B divided by length of A times the length of B. This gives us a number between -1 and 1. A score of 1 means the patterns are exactly the same. For price data, we usually get numbers between 0 and 1. Setting thresholds, we try 3 cutoff points: 0.6, 0.7 and 0.8. Only pairs above the cutoff get connected in the network. Higher cutoffs mean fewer connections, showing only the strongest relationships. For example, at 0.6, we might have 200 connections, but at 0.8, only 50. Weighted connections. The similarity score becomes the strength of the connection. So 0.85 is a stronger link than 0.65. We use these strengths when calculating important scores. Now let's look at the actual code. Loading data. We use pandas to read the Excel file. It has these columns: year, month, city, product and price. Then we group products into 7 categories like food and transport using keyword matching. Calculating similarity. One function builds our price lists, fills in any missing values with averages, then normalizes everything. Then we calculate similarity for all city pairs. If we have 30 cities, that's 435 comparisons for each category. Building networks. Another function takes the similarity scores and the threshold, then creates a network using network X, which stores two things: the weight in which is the similarity, and distance, which is 1 minus similarity. Measuring importance. We calculate 4 different ways to measure how important each city is: degree, how many connections it has; closeness, how close to everyone it is; betweenness, how often it's a bridge; and eigenvector, if it connects to important other cities. Making pictures. We use Seaborn for heatmaps and matplotlib for networks. Bigger circles mean more connections, and colors show different importance scores. Let's look at our main graphs and what they show. Heat maps. This colored grid shows similarity between all city pairs for food prices in 2023. Red means very similar. See that red cluster in the corner? Those are Punjab cities with the similar wheat prices. Darker colors mean less similar. Different thresholds. Here's the same data at 3 cutoff levels: 0.6, 0.7 and 0.8. At 0.6, almost everyone connects to everyone. At 0.8, only the strongest links remain. Notice Karachi and Lahore stay connected at all levels. That's a strong economic link. Different weighing methods. The left network treats all importance measures equally. The right one gives more weight to measures that vary a lot between cities. It's only important in measures that don't vary much. Ranking changes. This chart shows how cities move up or down the list when you change methods. Faisalabad drops 5 places. It is only good at correlated measures. Multan goes up because it's strong in measures that vary a lot. Time comparison. This diagram shows that every connection from 2023 still exists in 2024, plus some new ones. This means cities are getting more connected over time. So what does all this mean? Weighing methods matters. The entropy method, giving more weight to measures that vary a lot, showed that betweenness was the most different across cities. Cities like Multan that connect different regions became more important. This matters because these cities can help control how inflation spreads. Threshold effects. At zero point 0.8, we found three clear groups: Punjab cities, Sindh coastal cities, and Khyber Pakhtunkhwa, Balochistan border cities. At zero point 0.6, these groups merged together. This shows that cities are moderately connected overall, but strongly connected within their regions. Importance changes. Karachi stayed important under all methods. It connects to other important cities, but its bridge rule decreased at higher thresholds, meaning it's not the only path. Quetta always had low scores, showing it's isolated from other markets. Changes over time. From 2023 to 2024, we saw 23% more connections for utilities and transport at 0.7 threshold. This makes sense because the government standardized fuel prices nationwide, but fruits and vegetables became less similar, probably because different regions had different harvests. To wrap up, we showed that the entry method gives us more useful city rankings by focusing on measures that really differ between cities. Different thresholds reveal groups within groups. Limitations. Our analysis assumes simple relationships. It doesn't account for government policy changes during the year, and product categorization might have some errors. Thanks for watching.